Namaskar. Welcome to the channel Anka Anandaharan, that is extracting happiness from the teaching learning process of mathematics. Here we are discussing some of the problems from chapter 2. Now let us discuss for which vectors. Chapter 2 of Gilbert's book of Linear Algebra and its Application. The book name is Linear Algebra and its Application. Author name is Gilbert Strang, 4th edition, and these are the questions from the exercise part of chapter 2. So now the question is, for which vectors b1, b2, b3 those systems have a solution. Already observe here, both the system of equations coefficient matrix are in echelon form. If any coefficient matrix is non-singular, then for every RHS vector, it has solution and the solution is unique. So here, the first matrix is having 3 pivots. This is pivot 1, this is pivot 2, this is pivot 3. So it has full set of pivots. That means the first matrix, this matrix is non-singular. As it is non-singular, for every b1, b2, b3 belonging to R, it has solution. This first system of equation has solution. Equation 1 has solution. There is no doubt about it. But about the second, so in this case, here what is the coefficient matrix, and here the x3 is b3, x2 is to be obtained from the equation. Okay, so but x2 is what? b2 minus b3. x2 is b2 minus b3 and x1 is b1 minus x2 minus x3. Substituting will get x1. So here it has full set of pivots. Now the question, and this system of equation has solution for every value of b1, b2 and b3. Next question is for the second matrix. It is 1, 1, 1, 0, 1, 1, 0, 0, 0. Augmented part is b1, b2, b3. We know that if the coefficient parts rank and total augment matrix rank, they are same, then only the system of equation is having solution. In other words, if this left hand side is having a 0 row in its echelon form, then in the right hand side also there should be a 0. Otherwise, it will create problem. It will not allow any vector to any matrix, this coefficient matrix, it will not allow any solution, because there exists no vector for which 0 into x1 plus 0 into x2 plus 0 into x3 is not equal to 0. So this system of equation is having solution. So the second system of equation is having solution. So it has solution. System 2 or equation 2 has solution only when, if and only if b3 is equal to 0. So this is the case. Next is what it is telling. If we add an extra column to column B to a matrix A, then the column space gets larger unless, that unless gap will be, unless B belongs to C of A. That extra vector, if it is belonging to C of A, then it will not be having an extra columns in the matrix. Otherwise, in the column space, it will not get larger. If B belongs to C of A, the column space remains same. The extra vector B belongs to column space. If B is an element of column space of A, then it will not get larger. It will remain as it is. If B is not belonging to C of A, that implies C of A gets larger with the extra column B gets larger. Okay, this is the situation. Now give an example in which the column space gets larger. And first of all this. So here it gets larger, this case. So my one column is 1, 2, 0. Another column is 1, 3, 0. It is my A. And let my B is equal to 0, 0, 1. Clearly, we are getting that B is not an element of C of A. So this implies this implies B is, so here this B does not belong to C of A. So now my new A will be new A. What is that? 1, 2, 0, 1, 3, 0. It is 0, 0, 1. If we convert this, so it is new matrix is this one, and here after reducing it into echelon form, what we are getting? R2 minus 2R1 stored in R2. How much we are getting? It is 1, 1, 0, 0, 1, 0, 0, 0, 1. So finally, I have a matrix with 3 pivots. That means here all the 3 columns of the given matrix all 3 columns of the given matrix are linearly independent. Hence, column space of A is larger than, it is of dimension 3. C of A in the second case is of dimension 3 and it is of dimension 2. So column space of A, this previous matrix A, it has dimension 2, now it has dimension 3. Hence here it gets larger. But let us study this. It is B is equal to 1, 2, 0, 1, 3, 0. It is my A. What is the rank of A? It is 2, because after getting echelon form here, in this case, what you are getting? This we will get, we will study. Now, let the B is equal to the linear combination, one of the linear combination, 2, 5, 0. So clearly, after adding these 2 columns, I am getting my B. That implies my B is, so here B belongs to C of A. Now my new A is, what is my new A? It is 1, 2, 0, 1, 3, 0, 2, 5, 0. After getting echelon form, what it is? It is 1, 2, 0, echelon form, sorry, second row minus twice the first row gives me second row, new second row, that is 0, 1, here it is 1, 0, 0, 0. So here previously first two columns used to span the column space of the given matrix. First two columns were spanning the whole C of A, and here also the first two columns are spanning the whole C of A. So that means C of A, that is column space of A, remains same. I hope it is understood to the audience. So here my column space is same, C of A is same. Same. Okay, now last part of the question again we will discuss. What it is telling? Last part of the question is why AX is equal to B is solvable exactly when column space does not get larger, including B. So here the question is, if A included with B, this is my new A tilde B. Okay, here this if my C of A and is equal to C of A tilde, that means what? That implies, and implied by, B belongs to C of A. So if B belongs to C of A, that implies and implied by the system of equation has solution. Let us first discuss. So this, first of all, just will change the color so that we can differentiate that. Okay, what it is telling. So let B belongs to C of A. That implies B is equal to C1 A1 plus C2 A2 and so on Cn An, where A1, A2, A3 are the column vectors of A and B is a linear combination of columns of A. So that means the first column is multiplied with C1, second column multiplies with C2, and likewise nth column is multiplied with Cn to get B. So here, what is my solution then? In place of C1, I can write, so what is my solution vector? Actually, if x is equal to x1, x2 and so on up to xn, what exactly it means? This means in the column form notation, it is ax1 plus a1 x1 plus a2 x2 and so on plus an xn gives rise to my b vector. Okay, I hope you are getting. Otherwise, let me write down the system of equation. So a1, a11, a12, a1n, a21, a22, a2n, am1, am2, amn. This is my system of equation into x1, x2, xn is equal to b1 xn ठीक है is equal to b1 b2 and so on up to bm. Okay, so here this is my system of equation. Now suppose it is my a1 column, it is my a2 column and so on, it is my an column. So first column, suppose it is representing, so this is my a1 column, this is my a2 column, this is my an column. I have given these columns name as a1 a2 a3 like this. Now this column form representation of the system of equation is first column will be multiplied with x1 plus second column multiplied with x2, likewise plus nth column multiplied with xn gives rise to b vector. Okay, so that means here if I have a linear combination of columns, that means I have x1, x2, x3. What is my, in this case, what is my solution? X is equal to x1, x2 and so on, x3, xn, that is equal to c1, c2 and so on up to cn. That means if B is a linear combination of columns of A, then what I will get? That the scalars which are multiplied with the different columns to get the linear combination, those scalars, the coefficients are my variables or unknown variables or solution vector. They constitute the solution vector. Second is suppose. So here B is a linear combination, implied it is a solution. Similarly, next what we can prove? If it has a solution, so that is if Ax is equal to B has solution. That means I have x1, x2, x3 satisfying this equation, this equation. That means my column 1 into x1 plus column 2 into x2 and so on up to column n into xn is equal to B vector. That means B is a linear combination of columns of A. That means B belongs to C of A. So if my B belongs to C of A, it has solution. If it has solution, then B belongs to C of A. Already we have proved that, verified that if B belongs to C of A is not, C of A is not expanding with a new variable vector B when added. If it is not belonging, then it is giving the extension or larger C of A. Okay, so with this the question is answered. I hope you have understood. So whenever this column space does not get larger, that is whenever my B belongs to C of A, we have Ax is equal to B is solvable. Next question is, if this is A is any 8 by 8 invertible matrix, then its column space is R to the power 8. The question is why? Because here each column vector, suppose my vectors are here, A has, my column vectors are A1, A2 up to A8. These are my column vectors of A. So here all of them are elements of A1, A2, all of them are elements of A8, are elements of R to the power 8. Okay, or that means these are vectors, 8 different vectors. Now what it is, if it is invertible matrix, so invertible matrix, this matrix is non-singular. Any matrix is non-singular means it is having full set of pivots. That means all its column vectors are linearly independent. So I have 8 number of vectors which are linearly independent in a vector space having dimension 8. So that's why they form a basis for r to the power 8. That means their span or span of these columns means it is column space of A. So column space of A is my columns are forming a basis for r to the power 8. So that means my columns already we know our columns are basis of C of A. Now we got our columns are forming a basis for r to the power 8. One basis is generating the same basis. B is equal to A1, A2 and so on up to A8. Span of B is, by definition of column space, span of B is my C of A. And what is B? B is a collection or set of 8 linearly independent vectors in a 8-dimensional vector space. So R is 8-dimensional vector space. Any 8 number of linearly independent vectors of r to the power 8 will be giving me a basis. So that's why in that ground my B is a basis is a basis for r to the power 8. So B is a basis for r to the power 8. So r to the power 8 means that is what it is. So span of B is equal to r to the power 8. So 8 r to the power 8. So what we get? Span of B is C of A. Span of B is r to the power 8. So same basis cannot span two different vector spaces. So this implies C of A is equal to r to the power 8. What is actually r to the power 8? It is a r-dimensional vector space having maximum r number of linearly independent vectors. That is, any r number of linearly independent vectors of r to the power 8 can span the whole r to the power 8. And here A is non-singular, that implies every column vector in A are linearly independent to every other vector in the matrix. So this answer is understood. If not, then it can be asked also. So reduce A and B to echelon form. Find their ranks, which variables are free. Find the special solutions to Ax is equal to 0, Bx is equal to 0. Find all solutions. Okay, we will change the color. So what it is giving? Now my A is, just I am changing color because the answers are when expanded, it will not create any problem. So what is my A? 1 0 1 2 0 1 0 1 1 0 1 2 0 1. To get its echelon form, what operation? Already here 0 is there. This is my pivot. This is my pivot. Below it I should make every element 0. That is, I want to make here 0. So what operation I should do? R3 minus R1 stored in R3. How much it is giving? 1 2 0 1 0 1 1 0. Whenever it is same, we need not do anything, just directly we have to copy. So it is my new matrix. Already it is in echelon form because this is my first pivot. It is below it having 0. Second pivot below it I am having 0. So it is in echelon form. So first is it is in echelon. See, it is echelon form. Next part of the question is and find their ranks. So rank of A is, how many pivots we got in the echelon form? It is 2. So this is 1, this is 1. So it is 2. Next part of the question is, which are free variables? Suppose I have free variable. So here what will be? This is x1, x2. Here I will write. So this column, so free variable means ax is equal to 0. There what are the variables? So if I multiply this matrix, so ax is equal to 0, that means ux is equal to 0. That means my first pivot, it is 1 2 0 1 0 1 1 0 0 0 0 0. This into x1, x2, x3, x4, that is equal to 0 0 0. So here this column this is corresponding to my x1 column, this is corresponding to x2, x3, x4. So where my pivots are, this is a pivot, this is a pivot. So which variables are free and which variables are pivot? This is x1, x2, x3, x4. So here it is pivot, here it is pivot. A variable is a pivot variable if its corresponding column is having a pivot, otherwise it is free. So here last two columns are not having any pivot, so they are free. The corresponding variables are free. One part is over. Next is which are free variables, which are pivot variables. x1, x2 are pivot variables and x3, x4 are free variables. Next part, special solution. To find out special solution, we are interested to find out ax is equal to 0. So for any matrix A, ax is equal to 0 gives us the special solutions or null space vectors. To find out the null space vectors, we will, or basis for null space, what we will do? We will assign the free variable such that one of the free variable will be having 1, rest all free variables are assigned with 0. Similarly, here I will assign 0, here I will have 1. Now what are the equations? From here we have equations x2 plus x3 is equal to 0. Then it is x1 plus 2x2 plus x4 is equal to 0. These are the two equations. Now in this equation we will substitute x3 value to get our x2. So here x2 is minus 1, here it is 0. Now in this equation we will substitute our x2, x3, x4. So first I will put here x3 we don't need, x2 is here minus 1, x4 is 0. So just it is plus 2. So then what is our next condition for the second case? Here x4 is 1, it is 0. So that means I am getting x1 is equal to minus 1. Okay, plus symbol is there everywhere. I have substituted correctly. So these my, then what are my special solutions? Hence the special solutions are, we will write in a set. What is it? Here we can give more specific answers also. So here I can write 2 minus 1 1 0 comma minus 1 0 0 1. I can stop here also. If I have interest, then if I am not, I am having 100% confidence that I am writing correctly, then I will observe this vector, how I got. Which free variable is assigned with 1 to get this vector. So observe, this is my first vector. Here which variable is assigned with 1? This is my x3. So if I am interested, I can write here x3, comma, for the second vector x4. Means this first vector is multiplied with x3, second vector is multiplied with x4. In this format I can write. But even if I am not writing, still the answers are correct in examination point of view. Next, second part of the matrix, just we will observe. What is that? It is B is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. So let us find out its corresponding echelon form. R2 minus 4 R1 stored in R2 R3 minus 7 R1 stored in R3. First row no change, 1, 2, 3. Here is 4 times 1 is subtracted, it is 0. 2 times 2 is subtracted, it is from 5, so it is minus 3. It is 12 minus 6, so it is minus 6. 6 minus 12 actually. So here what will happen? It is 0. 7 times of 2 is subtracted. That is 8 minus 14. It is minus 6. And 9 minus 7 times. That is 21. 9 minus 21 means minus 12. Okay. So I have this. Now still it is my second pivot. Below it I have to make 0. This I have to make 0. So what operation is needed? It is R3 minus 2R2 stored in R3. Stored in R3. Okay. Or I can write here stored in R3. Okay. So now the new matrix is 1, 2, 3, 0, minus 3, minus 6, 0, 0, 0. So I have only 2 pivots. So that means rank is 2. So it is asking for rank. Na? Find the rank. So what is rank of B? Rank of B is equal to 2. And I have to multiply this with x1, x2, x3 to get 0 vector. So here my x1 variable corresponds to this column, x2 corresponds to this column, x3 corresponds to this column. So that implies x1, x2 are pivot variables and x3 free variable. The next question is pivot variables. It is x1, x2 free variables. It is x3. Now, how to find out the special solutions? We have to write in an equation. What are the equations it is getting? Minus 3 x2 minus 6 x3 is equal to 0. Okay. Another equation is x1 plus 2x2 plus 3x3 is equal to 0. These are two equations. Now let us substitute these values. So it is x1, it is x2, it is x3, it is pivot, it is pivot, it is free. In the free variable we will assign it with 1 because only one is there. One free variable is there. So here let us substitute in this equation. What we are getting? It is minus 6 this side plus 6. So x2 is equal to minus 2. Okay, minus 3 x2 is equal to 6 implies x2 is equal to minus 2. Now let us substitute these variables values. Here it is 1, here it is minus 2. So it is minus 4 plus 3, that is minus 1. That side it is plus 1. So x1 is equal to this much. So here, what about our special solutions? Special solutions are 1 minus 2, 1. This into which variable where we have assigned free variable? It is x3. This. If we are not writing this, then also it is allowed and it is correct. It is not incorrect. But it will give more information. Actually, what it is, if any vector is given to me, which is a solution of this, which is a special solution of this matrix, then that vector should be, we should be able to write down as a linear combination of the basis of the solution space. So in the basis, I will observe in the vector obtained the last component. Whatever value is there, here I will write that much. If the last component is multiplied with 7, then the vector will be 7 minus 14, 7. So if any vector given to me, how it is, what is the multiple? So that I will verify from this x3. So if x3 I am not writing, still there is no issue, which is because it is only one vector. That means that vector scalar multiple will give me the null space of this matrix B. B लिखना है A लिख दीजिए तो सब हाँ okay special solution. So this question is completed. Now we'll move to the next question. Find the complete solution. Find the complete solutions of XP. Okay, so first part. So first part, the given matrix is this one. It is one augment matrix. Directly I am starting from the answer. Okay, it is my coefficient matrix augmented with RHS vector. So what I am getting? I will do elementary row operation R2 minus 2R1 stored in R2. I will get 1, 2, 2, 1. No change here. 0, 0, 1 twice 2. This here it is not in row reduced echelon form. While complete solution case, we have to write down the coefficient matrix. We have to get the row reduced form of the coefficient matrix. It is a pivot, we got the echelon form. But in the echelon form, if all the pivots are 1 and all the non-pivot elements in the pivot columns are 0, then they are in row-reduced echelon form. But here there exists a non-zero value. This is a non-zero value. To make it 0, what should you do? R1 minus 2R, R2, because pivot is this second row, that's why I am doing this, is stored in R2. Sorry, R1. It is stored in R1. How much it is? 1, 2, it is 0, it is twice R2. So it is 1 minus 4, that is, it is minus 3. It is 0, 0, 1, it is 2. Now I got the row-reduced echelon form. So here, this is a pivot variable, this is a pivot variable, and my corresponding columns, corresponding variables name U, V, W. So here, what are free and what are pivot? Free are it is pivot, it is U, comma W, free only one, that is V. Okay, so how to find out XP? As we have already discussed in the previous video, it is UVW. What I will do? Directly, if it is in row reduced echelon form, mind it, then directly I can write the answer. So variable U is having value minus 3, variable W is having value minus 2, and all the free variables are having value 0. This is my XP. Variable W corresponds to second row RHS vector is here 2. Minus 2 only. It is 2. And here first variable it is minus 3. So it is minus 3. Okay. U variable corresponds to first row where the RHS value is minus 3. So it is minus 3. Okay. So this is my XP. So somewhere if I am getting little counting error, please try to rectify it. Okay, so next is I am interested to find out xn. So what are the free variables? U, V, W. So for xn, before writing this, so this I will not write. So for xn, what I have to find out? Rx is equal to 0. This is to be solved. Rx is equal to 0. This is to be solved. So that means what I will get from the equation? Please observe, this is not correct. Okay, what is? So here first variable is U. U plus 2V is equal to 0. U plus 2V is equal to 0. Another is W is equal to 0. So here W is equal to 0. Here what I will get? I am getting what I require then. There are three variables U, V, W. Already, so which is the free variable? Free variable is V. There I will assign 1. I will calculate the pivot variable. So it is free, it is pivot, it is pivot. So here from this equation W is already 0 and from this equation U is equal to minus 2. So what is my xn? Xn is equal to V into minus 2, 1, 0. This is my xn. So what is my complete solution? Hence, the complete solution is x is equal to xp plus xn, that is equal to xp minus 3 0 2 plus b times minus 2 1 0. This is our answer. I hope in this video we have discussed several significant concepts, and let me see how many questions are left. So for this series, let us stop the video. In the next video, few more problems we will discuss. Thank you for watching.